Good afternoon and welcome to the Half Hour with Premier Power. I'm Michael Holt, owner-operator of Premier Power, Inc. I'm an electrical contractor here in Lake County, and when I think electrical, the first word that comes to mind is safety, electrical safety. And we are going to talk about electrical safety today, and we're going to talk about when do you need an electrician, when do you bring them in, what's going on. I've got a couple guests with me today. I want to introduce them. First off, I've got my father, Mike Holt, who is an electrical expert. And we've also got Paul Lower with Wilson Management Group, who's a property manager. Paul, welcome aboard.
Thank you for having me.
You're welcome. Paul has a lot of experience with properties and situations, and so we want to bring you in as an
expert consumer.
An expert consumer. Yeah, that's right. Good point.
You could call me that.
All right. Let me go ahead and open the program up. If you have access to the internet, if you go to www.premierpowerinc.com, you might not do it right now, but you can make a note of that. Go to the important information link, and there's a lot of information. We're covering, do you need an electrician? And there's a link there you can click on, and it gives the information that we're going to be covering. So if we go kind of quickly and you want to print it out yourself or just read it yourself, you can go online and do that. So do you need an electrician? Who do you call? And what questions should you ask the electrician? So, son, I'm going to kind of open up the program here.
Sure.
And the questions are asking yourself about your electrical system. Do circuit breakers in your home or your commercial building trip often, or do fuses keep blowing? Do you have any examples where...
We run into that in older houses where in the kitchen primarily they have the microwave, the toaster oven, the coffee pot, and they plug them all in, and the breaker pops every single time. So what they do is they work around it, and they plug in the little extension cords to other outlets. But yes, in kitchens and older houses, there's a limited supply of outlets and breakers.
What about fuses? Is that a common thing in houses? You see many homes with fuses today?
You know, not really too many. I mean, they're definitely out there a lot, but we've gone maybe 5% of our projects have been with fuses, the screw-in type, yeah.
All right, got you there. And Paul, do you have situations where you find that, now let me explain something. A breaker tripping once in a while, it's just an inadvertent event. You know, you're just going to say, well, I wonder why that tripped. And then you turn it back on again, and you're okay if it happens once in a while. It's when it becomes a little bit more reoccurring that's like, wait a minute now, there's some, because the breaker's tripping indicating there's a problem.
Yep, and they indicate on 3 reasons: overload, short circuits, and ground faults. Now, another case where we
let me explain it. Overload means you plugged in our house, we have radiant heaters, little 1,500-watt heaters plugged into the living room, and then my wife plugs it into her office. Well, they're both on the same circuit, trips the breaker. She runs in her sewing room. She has an iron, and then she has a heater in the wintertime. Trips a breaker. That's overloaded, so it's too much. A short circuit is where a wire is failing, and it's
nicked somewhere. It's exposed. It got cut, maybe from vibration. Maybe it wasn't installed properly in the piece of equipment without a connector, so it hits the metal casing.
Eventually,
on an exhaust fan, we run into that. So yes. Now, another reason why is ground faults as well.
Well, ground faults are similar to a short. You have GFCIs that are tripping,
right?
Breakers.
You have AFCI breakers, which are arc faults. Now, arc faults sense arcing within that branch circuit, and those are generally located in your bedrooms. Now they're located more often, but we ran into a project where we had an AFCI that was tripping every 2 weeks all the time. And we found out the trend was happening is they visited the house every 2 weeks. So
wasn't this a rental unit or a vacation home?
This is a rental property for one of my property managers out in another community, but what it was is it boiled down to an appliance. They had an air treatment system that was plugged into the outlet, and it was tripping. And so there was a fault or a short or an exposed wiring somewhere in that appliance, and it was tripping the breaker.
So it might not even be the wiring that's causing the case.
No, it's not the wiring, it could be the wiring or both the appliance plugged into it, because anything plugged into the outlet is electrically connected.
Hey, Mike's going to jump in here.
I have a quick question for you. You said AFCI.
Yes.
What's the difference between? Because I've been paying attention each week with a GFCI.
Dad, go ahead and take it over.
All right. GFCI is a ground fault circuit interrupter, and that's where you have water and electricity, garage, your kitchens, your bathrooms, swimming pool area. So there's electric shock hazard. So you need to have those in there, and a lot of the older homes don't have them. You really should put them in there. AFCI is started in 1999, and it's expanded in its uses. It's an arc fault circuit interrupter. It's looking for wires that have not quite created enough of a problem to trip a breaker, but they're arcing inside your boxes. They're arcing inside your walls. Paul?
So they may not have a good solid connection so that when you energize something or you plug something in, it actually sparks across the
No,
circuit?
it doesn't spark across. In other words, it's continuously arcing. You plug in an old appliance, the cord is kind of broken, and the cord is kind of arcing. But it isn't enough to cause you to trip the breaker because it's not an overload. It's not like you got a lot of current. It's less than it would take to trip a breaker, but it's enough to cause a fire. So when you have arcing faults, the arcing fault will be below the sensing of a typical breaker. A GFCI, in order to sense this ground fault condition, is electronic.
And GFIs, don't mean to cut in real quick,
Go ahead.
but GFIs are in the areas of water. AFCIs were generally back in the bedrooms because when people were sleeping.
Well, now it expanded from bedrooms now.
To almost everything other than the kitchen.
So AFCIs are computers. They're electronic. So they're kind of opening and tripping under weird conditions because you have a fan and there's a fault in the fan. Now, it wouldn't be enough that it would trip a breaker, but the electronics say, well, there's something not right. So you have standard breakers, GFCI breakers, and AFCI. And as we get more into electronic, we're having more of these problems. And the crazy thing about new technology like an AFCI, Gator Mike, when it first came out, see what it's doing, it's looking at the wiring and it's checking the current, saying, is this normal? And if it finds something that's not normal, it trips. Well, in order to determine whether it's normal or not, the computer has all these signatures that it's looking at. And so somebody had to go in and say, okay, this is considered a fault. This is not considered a fault. Well, vacuum cleaners, fans, a lot of these things came out that were normal appliances, not a problem, but the AFCIs found them to be faults. So we've probably gone through the product development now, but still there's a lot of AFCIs, old ones out there that have been put in recently in the last few years. But did I answer your question on GFCIs, AFCIs?
Yeah, absolutely. Thank
One
you.
is for arcing faults. One is for electric shock. And then your typical breakers are not going to protect you against an arcing fault, and it's not going to protect you against a ground fault. So the trend, the way the National Electric Code is going, is that let's get AFCIs in all of the circuits in a house now, and that's where we're at now. All right, anything else on circuit breakers, Paul? Did you have any cases where you had circuit breakers tripping on a regular basis?
Yeah, recently we had a duplex that was built probably in the 50s, and the tenant kept calling because he kept tripping a breaker in the kitchen, kept tripping a breaker in the kitchen. Sent an electrician over, and ultimately he was running the microwave and brewing coffee at the same time, and it's all on the same circuit.
Yeah, who would want to? I mean, come on,
Yeah.
is that
Exactly.
stupid or what? Microwave something and brew coffee. I mean, come on, buddy, do one or the other, but that's it.
Well, and
That's why the rent's at whatever the rent is.
Well, exactly. Then we had to explain to him. I mean, that's a problem you're going to have in an older property. The property had been rewired, but they didn't add any additional circuits, so you're just drawing too much.
In my case, my breaker trips all the time in my house. Is because my wife is ironing and she has a heater in there and she looks at me and she's like, well, what's going on here? I'm like, well, babe, I mean, come on, you either iron or put in the heater, but you can't do both. So we're building a new house right now, and so because of that, we're actually making sure that each of the bedrooms are on a separate circuit because we use these little 1,500-watt heaters for the purposes of heating up each of the rooms so I don't have to heat up the whole house. All right, I'm going to move on to GFCI outlets and where they are required to be had. Son,
Yes.
GFCIs, we talked earlier because Gator Mike asked that question, are in bathrooms, outdoors, kitchens, swimming pool areas, wet locations. Now, it started in 1971, and the requirements have expanded. Do you have any cases where you recommended?
This morning we're on a property, and one of our larger residential customers who has multiple properties thought that GFIs are only required right next to water. And so he's got, 5 or 6 or 7 outlets in his kitchen. He thinks he only needs to have one where all those circuits are supplied by, he's got like 5 circuits in this older house. And so in that kitchen, people...
But can't you just put one receptacle and it picks all the other receptacles up?
No, because they're all in separate circuits.
In that case?
In that case, yes. But, I mean, we could, of course, want to do that. But no, in this case...
All right, we want to move it here. So just make sure that if we have wet locations, you have GFCIs.
And you can wire GFI incorrectly, and it won't reset and won't it won't operate properly. So that was another problem why I came out there is they can't get the GFI working. They tried to wire it themselves, and they couldn't do it, and we went out there and rewired it.
Yeah, it's real you really don't want to be wiring.
No, you want to have a licensed electrician doing any electrical wiring with connections and terminations.
Especially now we're
absolutely.
getting computers and all these devices.
Even more so.
I'm going to move on to extension cords. Paul, about GFCIs. You guys have problem with GFCIs tripping, or not really?
Not really. Don't see that a whole lot. Most people understand how they work. And
Go back and reset that
Go
button.
back and reset and move on.
Okay.
All right, extension cords. Son, anything that you're seeing uses of extension cords?
One of our larger commercial customers had extension cords zip tied and permanently used in their
Through the
warehouse
ceiling,
through the
all over the
ceiling,
place.
because they didn't have convenience outlets where they were located at, so they didn't want a high electrician out there, so they ran the cords. And those aren't listed for permanent use, and they're flexible. They've got they don't have a very tough outer coating.
They're not sized.
They're not sized properly. They're very they are sized smaller, but you can hit a little nick in there and get in it.
Yeah. So that's it. You don't want to be having extension cords running temporary. An extension cord is for a temporary use, but not something on a regular basis.
How about a power strip? Is that considered an extension cord?
No, a power strip is not. And that's a great question, Paul. Power strips are designed. They're called relocatable power taps. They're designed to be plugged into a receptacle, but they're not designed to be plugged into an extension cord. The listing of that product, and they're not listed to be plugged in daisy chain. In other words, you can't take one, plug it into a receptacle, and then take another and plug it into that one, and then and daisy chain it. So a relocatable power tap, or those plug strips,
I'm going to cut you off.
Go ahead to be used right into a receptacle only.
We're going to a break. We'll be back in a couple minutes. Thanks for joining us.
Call us on my 790 AM at 352-787-9523 and get a free service call.
All righty. All right, welcome back to the show. We were talking about electrical safety and when do you need an electrician? Who do you call? What questions do you ask? Dad, go ahead and pick up on the last topic.
Yeah, let me go on here. We talked about extension cords, and people use them, and they're not realizing the danger. I need to move on to number 4.
Now, real quick, we're looking at a sheet here that you printed out from copper.org. This is actually a company.
Oh, that's where you go to your website, premierpowerinc.com, important information, and click on that link that says, do you need an electrician?
Right.
All right, number 4.
Yeah, for listeners who are joining us on the show, we have all these questions we're asking came off our website. Yes, so.
All right, number 4, is there rust on the main electrical service panel? Is that much of a problem with that?
Mm-hmm. Openings that are unused or installed improperly on a panel outside by your house. We have an example out on a property where on a residential barn they had a panel and all the breakers, all the screws were rusted and shorted, and so we actually had to remove and replace a large quantity of the breakers. They were not working at all.
So the breakers weren't even working.
No.
They just all corroded out.
Yep. Yep.
Well, beside them not working is the danger, because when you have moisture and you have high resistance contacts, and that's when you have a fire. Anytime you have resistance and corrosion, you have a fire.
Heat.
I have an example of that as well. In a previous job that I had, I worked for a company that had a commercial pool, and in that pump room, they had electrical, obviously, to run the pumps, and there was a panel there, and you would go down there, and the panel was just covered in rust.
Wow.
Pulled it off one time, and everything's corroded on the inside, and it had to be rewired.
Right. The screws are all broken. Things, it's tough to work with.
I'm going to move on to number 5. Do the lights dim when appliances turn on?
Lights dim on 2 cases, on when the appliances turn on, like you said there, or also yes, we run on properties where the lights are dim on appliances. Recently,
now, what causes them to dim? Are you familiar with that?
The high inrush current of the appliance, but I don't know much about it. But if you want to jump in there,
let me explain that. If you have an air conditioner, high efficiency air conditioners, when they start, in order to get that high efficiency, they have a very high what is called inrush current. It comes in really strong. Well, the problem is when it comes in really strong, it causes incandescent lighting to kind of dim. And the light, your eyes are incredibly sensitive to a slight change in incandescent lighting. Compact fluorescent fixtures, regular fluorescent fixtures, LED lighting, you won't notice that slight dim. If the air conditioner kicks on and your lights dim just for a fraction of a second, that is not dangerous. That is not a problem. That's a product of higher efficiency appliances. The second case
is, on a property this week, we had a situation where the customer called us and the lights were dimming, and we get out there.
But were they dimming like an air conditioning lighting?
No, they're dimming just normal use. No, the AC wasn't even on or anything.
So the one light was brighter, and then it got...
It was dim, and then it would get brighter. So it was dim.
Now if your light is... But when it got dim, it didn't do it for a fraction of a second. It went dim.
It was already dim.
It was already dim.
So I turned it on, it was dim, and then you go to hit on another switch, and then it would get brighter. It was
on a 3-way switch setup.
No. I thought it was, but it wasn't. But it ended up being that way temporarily. What it was there was an open neutral problem on the electric utility company.
Well, hold on, let me explain this.
Now that's kind of tricky.
If you're in your house and your lights are acting kind of strange, in other words, they're kind of bright, and then all of a sudden they get kind of dim. I remember as an electrician, I went to this old lady's house, down in South Florida. I was down there, and she goes, you know what? I have a problem. I said, what is it? She goes, well, when I come in and I turn on the kitchen lights, it won't come on. But when my husband turns on the TV, then the kitchen lights come on. And I'm like, well, then what's your problem? Just turn on your kitchen lights with your remote. You know what I mean? She goes, no. And that means that there's been a failure of a wiring. Anytime the lights get dim and they stay dim, then they get bright and they stay bright, and then they get dim and they start moving and changing, then you have a very, very serious problem. And what that will do is there's an overvoltage condition and an undervoltage condition. Your GFCIs, Gator Mike, they're going to get toasted because they're electronic. They're designed to operate at 120, not operate at 160. What happened in that case? Did you have AFCIs?
No AFCIs on the property, but GFI breakers failed, GFI type receptacles failed, smoke detectors were burnt up, their surge protection was burnt up. So that open neutral created an overvoltage where things were operating from 120, but they're operating at 160.
So you actually measured the voltage.
We measured the voltage, and then on the other side of it, because it's a 240 volt circuit coming in, service coming in, the other size, they were only reading 90 volts.
So you had 90 volts and you had 160.
160.
And now there's Murphy's Law, Mike, Gator Mike, if you don't know this. In electrical systems, the most expensive piece of equipment will always sacrifice itself to protect the least expensive piece of equipment. Your flat screen TV of $2,500 guarantee will protect your popcorn
Maker.
Let me get in here real quick and give you another example on that one property. You could smell smoldering smoke, something would happen. And so that overvoltage on the GFI receptacles, on the GFI breakers, on the little strips that they plugged in, those had all burnt up, so you could smell it. So
you smell those electronics being toasted.
Yeah. All right, let's get back on track here.
All right, number 6. Electrical switches outlets feel warm or tingly.
They had those dimmer switches that are rated for a certain wattage, meaning you can get a switch that is intended to be used for only so many bulbs on that fixture, where we've come to jobs where they've had 5 chandeliers on one switch, and that switch is just hot. I mean,
So it's a product designed for a certain number of light fixtures, but then they place a lot more light fixtures on there, overloads that equipment. See, now, Gator Mike, overloading that dimmer like that, let's say it's supposed to take 600 watts and they put 1,000 watts on there, it's not going to immediately go bad, but it's going to get hotter and hotter and hotter. A regular breaker is not going to see that because it's not a fault. An AFCI is not going to see that because that's not a fault, and a GFCI does not see that. So the product itself gets super, super, super hot, and then it ignites.
That's right, and it's not an overload because on that whole circuit, on the general idea, on the general concept, it's not overload.
So the electrical system will never protect itself because the product itself was improperly used. So if you put your hand on a dimmer, on a switch, or a receptacle, and you feel any kind of warmth, now it'll always be a little warmer. But it should not be, oh, wait a minute now, there's something wrong.
It's hot, like you can put an egg
and you know
on
what,
it.
you don't want to take a chance. If you feel something you're not comfortable there, call an electrician, call PremierPowerInc.com. Michael, you want to give him your phone number?
Yeah, go ahead and you give me a call. My phone number is 352-978-7015, or you can visit me on the web at PremierPowerInc.com. And if you don't feel comfortable contacting me there, you can always email me, Michael@PremierPowerInc.com.
Let's talk about these plug strips. Unless, Paul, you have anything to say? All right, these plug strips, what you were talking about, can you plug in a plug strip? And the answer is yes, you can use a plug strip to plug in there. But only one can go in there. And there's nothing dangerous about that. They're specifically designed for that application. It's just you got to be careful that, how you do that.
I've seen in a dormitory situation that was built in the 60s, and it was, we're now in the 2000s, and if you go into a dorm in a school, kids bring in refrigerators and microwaves and
toaster
ovens and a hot plate and a coffee maker, and there's one outlet in the room because in the 60s,
I remember Belinda when my daughter was
in the
college,
60s that's all they needed. Nobody had any of this other stuff, and we walked into a dormitory room one time, and there was literally 4 of these strips daisy chained together, one after the other, and then an extension cord in one of them running something to the other side of the room.
No kidding.
Yeah,
that's not good, by the way.
No, we knew that.
Okay. All right, let's go on. The next one about does it accept 3-prong outlets?
Okay.
That's your 2-wire receptacles.
Their older houses back then, they only had 2-wire circuits. They had those receptacles that only have 2 prongs in them, so you can't fit any modern day appliance into it. And those are hazardous because there's no equipment grounding conductor there, and so there's no way to facilitate a fault. But
what are people doing?
They'll buy those little
cheaters,
the little cheater plugs. That way, it it molds. It goes from your appliance plug, and then it plugs into the outlet. Yeah.
Now, is that just a simple fix of just buying a new outlet and just wire it in, or do you have to run in another circuit to that plug?
Okay.
Or how does that work?
For a 2-wire circuit, if you want to install a 3-prong outlet to plug in modern-day appliances, that you can either A, rewire it, which is very costly in remediation, or B, you install GFCI protection on that circuit. You either A, do it at the breaker. That way, everything on that breaker, on that circuit, is GFI protected, which is the way that I would route it. Or sometimes if that's not feasible, you can put a GFCI type receptacle on the first outlet of the circuit, and everything protects it. So the GFI makes up for the 3-prong, and then you can put 3-prong outlets
And
down.
that's the electric shock hazard we're talking about, Gator Mike.
Yeah.
The GFCI protects you against electric shock. Since you had no ground wire, because it's a 2-wire receptacle, there's no ground wire saying, okay,
Right.
if you put in a regular ground type receptacle that is GFCI protected either at the panel, the electrician puts it in, or at a receptacle before that receptacle that protects that receptacle, or that receptacle,
Right.
then you provide the electrical shock hazard. Because the breaker provides protection against overload, short circuits.
So that's a good answer. That's a good. I've run into this before with older homes that we've managed, and sometimes an electrician will tell the homeowner that they've basically got to rewire the
Oh,
entire
no
house.
way. No, not at all.
And so it's good to know that really what you need to do is just upgrade it to a GFCI system, which can be done a lot more reasonably than rewiring the entire
Oh,
home.
it's huge,
And you know
huge
what you can
cost.
do?
Oh,
It's
real
just-
quick.
But-
What was I going to talk about? I was going to.
Okay, if it comes back,
Yeah.
you can just go to the panel, right, and just change all the breakers to GFCI breakers.
Right, and then the plugs can be changed to 3-prong.
Then all the receptacles can be changed.
And for all practical purposes, the wiring that's been installed behind your walls, that's fine. That'll last forever.
And the thing is, these old type houses, the wiring is so old. We're going to talk about the wiring is so old and crumbly that you're better off putting it at the panel. Because as soon as you take a receptacle out, let's talk about crumbling. That's the next one. Let's talk about crumbling wiring.
The boxes in these old houses like this are so small. The little handy boxes. I mean, they're tiny. GFIs have a hard time. I'm working on a job
you're right
tonight,
about that.
so they're very small. GFIs have a lot of area. They're thick. They're bulky, and they're tough to fit in there with your wiring. And then the old wiring, you try not to touch these things because once you touch it, you own it, and then you have to replace the whole circuit
Yeah,
or
because
a wire.
Michael will go in there and he'll say, okay, and he'll pull the receptacle out. All those old crumbly wire just totally
Falls apart.
disintegrates, falls all the way
And
back
it's
to the box.
and then you could do.
And now the owner's like, well, wait a minute. Now I called you.
You
You're
touched
supposed to
it.
get- it's
Hey,
yours.
not my problem.
And now you got a short that you got to fix, or
Yeah.
completely rerun the circuit.
Right, but every time you touch, everything you touch keeps getting, before you know it, you're living in there.
So panel's the way to go. Think electrical, think panel, think
think
safety.
safety.
Yep.
All right, let me cover one last point here. Maybe a house hasn't had any electrical service upgrade.
We have properties that have a little tiny little 60 amp service, and the thing is so small you want to talk real quiet when you see it, real soft because it's so tiny and little.
So cute.
Oh, it's so cute, and you want to put some flowers on it because it's so little. But you have.
But wait a second, but 60 amps, let's put it in perspective. What you really want is a 200 amp service.
Well, the minimum required. I mean,
No,
the recommended one is 100 amps, but
Right.
but the newer houses now have 150, 200 amp, but 200 amps the way to go.
I would think so. I mean, when you consider a modern house has a high efficiency air conditioner,
Right.
you've got a refrigerator, you've got every modern electrical appliance.
Tell
you
us
can
that one
think
story
of.
about that 160 amp, 100 amp service where they had all those things. What was that?
There's a property down in Miami. One of my customers has another friend of theirs, and they have a 30. They just bought a house, and they added over the years, and it's a 3,700 square foot house, and they've got a 100 amp panel, which for that size of the house is nothing. I mean, that's a little.
What were some of the loads?
They've got 2 washer rooms. They have multiple water heaters. They've got all kinds of equipment, tankless water heaters. I mean, 2 kitchens and all kinds of stuff. But I'm hearing the cue music here, so we're coming to a close. I want to thank you guys for listening to the show. If you guys have any questions or concerns, feel free to call me at 352-978-7015 or visit us on the web at premierpowerinc.com. Thank you. Have a great day and be safe.